Okay, so this is 1.2.2, and I just wanted to go over a couple of these questions with you guys, so you're not just hanging by yourself. Okay, so the first one I want to go over, because the other ones were just your opinions, drawing the spinners, all that good stuff, and then your thinking. That's what I want to look at. This one, so 1-64, it says use the data you collected in problem 1-63, right? The spinning of the spinners, to answer the following questions. So it says use your data to write the experimental probability of each of the following as a fraction, decimal, and a percent. Okay, so the first thing you need to know is what is experimental probability. This right here is what we're talking about. Experimental probability is what actually happened. Okay, so we talk about experimental probability, we talk about theoretical probability, right? So theoretical is what we think will happen. Experimental is what actually happened. Okay, so we actually spun the spinner. We did that, right? And so now it's experimental because something actually happened. We're not just guessing, we're not just predicting or anything like that. Okay, so the first one is the spinner lands on purple. Now, when you see this on a test, you're going to be seeing this, probability of purple, right? And when we do probability, this is always going to be what you want out of what you have, okay? So thinking about that lottery, when you buy one ticket, that's one that you want to win out of how many options are there total, how many millions of people are buying lottery tickets, right? Okay, so if we want purple, I need to look at how many are actually purple, right? So if I look at the chart, here is 18. There is 18 purple, 18 times we spin purple out of the total, right? So how many do we have total? And if I look at the total there is 48. So this is going to be 18 out of 48. Okay, and then we simplify our fractions. So I'm going to go ahead and do that. I'm going to divide both the top and the bottom. Let's start with 2. I know I can do more than this. I can do 6. If I do this, 18 divided by 2 is 9. 48 divided by 2 is 24, and I can still divide, right? So I'm going to keep in simplifying. Divide both of them by the same number because I'm not changing my fractions. 3/3. This will give me 3/8. This is my experimental probability of spinning and landing on purple. Okay, and then these are our big ones. We're gonna do, either we did or we will do a lesson on this, okay? My next one that I'm looking at is the probability of green or orange, okay? So looking at this one, what I wanted to see is what I'm happy with, right? So what do I want in this situation? I want green or orange. That means I want these 2 options, okay? This is what I want. I want 18 and 12. I'm okay with either one of those. If I'm happy with green, if I'm happy with orange, right? I have all those lottery tickets and I would win if I landed on green and I would win if I landed on orange. Then I have 30 options out of the 48 total for green or orange, okay? And then the same thing, I'm gonna simplify my fraction. Now I know that I can divide both of these by 6. This is still a big one because I'm not changing my fraction. I'm just dividing it by 1, so it says the same. Going straight across, 30 divided by 6 is 5. 48 divided by 6 is going to give me 8, and there is my experimental probability for green or orange, okay? And I would be happy with either one of those, okay? Checking the other ones, let's go through this. If your spinner were to spin 15 more times, how might this change your answers for part B? So looking at if I were to keep spinning, the whole thing about experimental probability is the more you do it, the closer you get to the theoretical probability, okay? What that means, right? When I flip a coin, my options are either heads or tails, right? Heads or tails. Now, it's supposed to be a 50-50 chance, 50%, 50%. Okay, what that means is if I were to flip a coin 100 times, that means that 50 times I should land on heads, 50 times I should land on tails. Does that always happen? No, right? But the whole thing about spinning more times is the more times you spin or the more times you flip a coin, the closer it should get to that probability. The closer it should get to half of the time it lands on heads, half of the time it lands on tails. Does that make sense? Let's go. Would you bet? Okay, so here's the actual spinner, right? And I hope you didn't look at this beforehand because that would have ruined the whole mystery spinner-ness of it. Okay, and so again, when I'm spinning 15 more times or 40 more times or 100 more times, it should get closer to this. Okay. Actual differences. Estimate the theoretical probability for getting each color on your teacher's spinner. So for this one, my theoretical probability, I don't need to estimate for this one. If I look at this, how many slices? So if I were to find the probability of purple, right? Theoretically now, right? So we haven't done any spinning yet. We're just guessing of what's going to happen, right? So for this one, how many purples are there? There's 1, 2, 3 slices of purple. So for that, so that's, oops, P purple, right? Is going to be 3 out of how many slices do I have total? Now I have 6 slices total. This is 1/2. Okay, so if half of your spinner is purple, then it's more accurate to mine. Okay, if I were to look at green, so the probability, I don't have room, probability of green, right, is going to be 2 out of the 6. So here's the 1, here's the 2. That's what I want is green. Out of how many do I have total, which would be 6. And this simplifies to 1/3. Okay. My last piece is orange. So if I want the probability of orange, I know this is not orange. I don't have an orange color. Okay, but if I want the probability of orange, how many oranges are there? There's 1. That's what I want. Out of how many do we have total? There is still 6, and that is simplified. Okay, and then continuing with that, if I wanted purple or green, right, I would be happy with either of those. Now I will be happy with this one, this one, this one, this one, and this one. Okay, and so on. Let me clear this. Okay. Comparing if the spinner is spin the number of times below. So this is what I want, right? Okay, last piece. The spinner was spun 6 times. Right? How many times would you expect it to land on orange? Now, this is where we use probability. This is where we use it to predict what is going to happen, right? So people, when they're counting cards, so it looks like when they're cheating, when they gamble, what they do is they know that there's a certain amount of cards, right? There's four of each card, 4 aces, 4 kings, 4 queens, 4 jacks, right? And they know the probability of what the next card is going to be. Because once I deal out some cards, that means it's not in the deck anymore. So if I'm dealing all of these like 2, 3, 4, 5, 6, my likelihood, the probability of me drawing a king or a queen or a jack or an ace, it's higher because there's less of the other ones, right? So that's how we use it. So if I have the probability of orange, right, this is 1/6 already. I'm going to use this theoretical probability to predict what is going to happen, okay? And the way I do this is fractions. So for 6 times, what I would do is I have the probability of 1/6. That's what's given to us. Now, if I wanted to find out of 6 times, how many times would it land on the orange, right? You can see that these are completely identical. It doesn't change, right? And what the theoretical probability means is if I were to spin it 6 times, it should land on orange once. Does that always happen? No. Okay, next one. So if I still use the same one, 1/6, this is my theoretical probability, but now I'm spinning 48 times, right? How many times would I land on orange? Definitely not 1. It should be more than that. Should, right? So what am I going to do? How do I go from 6 to 48 in my denominator? What I do is I multiply by 8. If I do it in my denominator, I do it to my numerator as well. So multiply that by 8, right? That means 1 times 8 is 8. That means that it should, right? If you spin the spinner 48 times, it should land on orange 8 times. Should, okay? And that's how we get our answers for that. And I can use any amount of times, and I'm just converting my fractions. That's all I'm doing, converting fractions. That's probability. Okay, so the next one. Oh, that's it. Okay, hopefully that clears some things up. Hopefully you guys didn't look at the spinner before actually going into my mystery spinner. And I hope that clears a couple things up between theoretical and experimental probability and all that good stuff. Okay, thank you.